Hello, 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 hello. Hello. Yes, I guess now it's functioning perfectly, guys. I'm really sorry for the delay. And okay, so we are starting today's lecture. This is your function part 2. My bad, I couldn't change it. Okay, so today we'll be studying about the types of different function and their graphs, and we'll also be studying how to draw different functions graph using standard functions graph. Okay, and before that I would request you guys to just quickly revise what we studied yesterday. So we studied the definition of function, we also studied about the domain, codomain and range, classification of functions. Okay, so I hope you will be able to recall it. So we had one, many one, into, onto, domain, also the definition of domain, codomain, range, and the mapping part, mathematical proof, everything. Okay, so about me, yes, hi, I'm your mathematics teacher Nishant Khanduja. So I have 8 years of teaching experience. So I have been teaching people personally. So I was an individual teacher. I traded in US and Canadian markets for 2 years. I graduated and post-graduated from IIT Bombay in aerospace engineering. I also got rank 1256 in IIT JEE and AIEEE 363, and RPT rank was 4. Apart from that, let me tell you an interesting fact about me, which made me just join Unacademy and teach you guys. The reason is, when I was preparing for IIT, I didn't join any coaching institute. So I always think, how should I inculcate or how should I share this knowledge with other students, those who are preparing for these competitive examination, if at all they can't go to these coaching institute. Because generally people, those who are there in tier 3 cities, tier 4 cities, or maybe villages, they can't afford to go to these coaching institute, but they can be at their places and they can still study for these competitive examinations. So that's what I have in my mind, and that's why I'm here on Unacademy, so that you guys can sit at home and study. So in this we are running a huge campaign, that is Crack IIT JEE, and that is India's largest campaign. And on Unacademy platform, if you go to Unacademy platform, you can just install the application, that is your Unacademy learning app. There you can have daily live classes. These live classes are different from YouTube, let me tell you guys. There you have very personal experience, and it gives you offline classroom experience. There you just sit, you try to have quizzes, so everything, you can have personal interaction. This is here we also provide you guys structured courses. So you don't need to you don't need to look for other many books, many questions. No, everything is sorted here. Every teacher has finalized good specific questions for you guys, so that you can just in minimalistic time you can just solve them. You have got live tests and quizzes here, and unlimited access of the recorded videos as well. Let's say if you miss any video, it's okay, you can just watch the video tomorrow or day after tomorrow, or wherever you feel like. You can just revise the syllabus. And then we have another subscription, that is your iconic subscription. So this is different from the plus subscription. So apart from having plus subscription facilities, we have got here personal coach. So this personal coach will look after your growth. He'll tell you, he'll try to strategize your strategy for the examination. You also get a study planner. So sometimes I have seen people, those who love to study in night, maybe daytime, and someone is having this strong part in chemistry. So based on that, they plan your study. Apart from this, you also get test analysis. When you're writing the examination, it also tells you, okay, so exactly in this area you're getting good marks, here you're losing marks, and how you need to manage that you don't lose more marks, and you score really well. Okay, so all these come only on one application, that is your Unacademy learning app. So when you go to this app, you can just buy this subscription, either plus or iconic. So when you buy a plus subscription, you have got 3 options: 6 months, 12 months, 24 months. You can choose either of them. I would suggest, since you are going to study with us, so go for a 2 year subscription, so that you don't need to change your teacher. This teacher will be looking after your curriculum, your progress in the course, everything. And let me tell you guys one more thing. See, this is all about me, right? I'm talking about. You get other teachers also for other subjects from all over India. You also get brilliant teachers. I call them superstars in coaching institutes. They are there on these platforms. You can just come, you can attend their classes. So all these things for 2 years, that comes in 2033 rupees per month, and you have to pay the exact one amount, that is 50,400 rupees, after applying my coupon NK001. Once you apply this code, you get 10% off. If you go for Iconic subscription, that costs you for 2 years, that costs you 86,000. But if you apply my code, you get 10% discount, and that becomes 77,400 rupees. Okay, so I hope, yes, you will be subscribing these packages soon, and you can see me on Unacademy Plus and Iconic. Okay, so let's go ahead. But before going ahead, I would request you guys to just bring all the energy here, all the concentration here for this class. So I would request you guys, just close your eyes and let's meditate for 5 minutes. Okay, close your eyes. Breathe in, breathe out. Inhale, hold your breath, exhale. Inhale, hold your breath, exhale. Just don't think about any pressure, any competitiveness towards your friends, nothing. You are here just to learn. Don't think about what will happen in the game. No, don't worry. Don't worry about anything. It's just you are here to learn. That's it. Just focus here and just pray to God. You will be focusing here in the class. There should be no distraction when you are studying something. Okay? When I say 1, you inhale, hold your breath. When I say 2, 3, 4, gradually exhale. 2, 3, 4. 1, hold your breath. 2, 3, 4. 1, hold your breath. 2, 3, 4. Now when I say 1, 2, 3, you are going to gradually inhale. 1, 2, 3, and then exhale. 1, 2, 3, exhale. 1, 2, 3, exhale. 1, 2, 3, 4. Now open your eyes. So how are you feeling, guys? I hope all the positive vibes, all the concentration here in the class. So let's start our class. So today we'll be studying about type of functions. So we'll be starting from the very first function, that is your polynomial function. So this polynomial function is represented by f of x is equal to a n x. Just wait a minute. Let me just take out the print pointer. Just wait for a minute, guys. Okay, so this function, polynomial function, is being represented by a n x raised to n plus a n minus 1 x raised to n minus 1, and it will keep going till a1x plus a0. Here, this a n, this cannot be equal to 0, first. Second, all these a n minus 1, all these coefficients, they are real numbers, or we call them real number constants also. This a1, a0, all these. And this n, the maximum power of x, this is called the degree of this polynomial function. Okay, now the question is, the domain of this function is real number. It is defined for all the values of r. Now range depends upon its degree. Now based on its degree, we call it, let's say if n is equal to 5, I'm taking the example, we call it fifth order polynomial. If n is equal to 4, we call it biquadratic. If n is equal to 3, we call it cubic. If n is equal to 2, we call it quadratic. If n is equal to 1, we call it linear function. One more thing, see, when you look at all these things, this n will always be, and this is going to be an integer, only positive integer, or I can say this belongs to natural number also. It will be a positive integer. So that means what? It will belong to natural number. Okay, now in this 11th standard, majorly we'll be studying about quadratic. So quadratic polynomial function that looks like f of x is equal to, I'm writing the standard form for that, ax square plus bx plus c. This is the standard form. Now for this standard form, if I want to draw a graph, let's see how does it look like. It can look like this, it can look like this also, it can look like this as well, it might look like this also. So now for which particular case we will be having these graphs, so how will we determine that? For that, what we'll be doing is, see, this is only possible whenever we get concave upward thing. So concave upward thing is possible when the coefficient of x square, that is your a, is greater than 0. And a is greater than 0, then we have concave upward. If a is lesser than 0, then we have concave downward. Okay, now how can we determine whether it is going to cut the x-axis or not? How will we determine that? So for that, we play with discriminant. If discriminant is greater or equal to 0, then either it touches the x-axis or cuts the x-axis. If d is lesser than 0, that means it is not going to cut the x-axis. So for these cases, it is not cutting the x-axis, that means d is lesser than 0. And here this is greater or equal to 0. Now you might ask, what is this d? D is called discriminant. The value of discriminant is b square minus 4ac. Okay, now let's talk about other things also. Now if I want to talk about its domain, so what will be the domain of this quadratic function? So domain will be all the real numbers, because this is defined for all the values of x. But when it comes to range, so range will be either, let's say if it is concave upward, it would start from here, from this point. This is called vertex. It would start from here and it will go till infinity. But if it is concave downward, then it would start from minus infinity and it will go till here, till vertex. So how to determine the value of this vertex? So for that, what you can do is, I can just tell you this vertex value, the maximum, the minimum value here when it is concave upward, it is minus d by 4a, and here it is again minus d by 4a, but for this concave downward it is called maximum value. So for, let's say, when a is greater than 0, when it is concave upward, so we'll have minimum value, so minus d by 4a to infinity. But if a is lesser than 0, then it would start from minus infinity and it will keep going till minus d by 4a. Got it? Okay, so I hope till here everything is clear. If you have any doubt, you can just leave a comment. Leave a comment. And okay, Adya, hello. Tushar Royal, hello. Rajesh Pandey, hello. Yes, I welcome you all, guys. Okay, so let's go to another function. Now another function is rational function. So this rational function is basically a function which is having two different polynomials in fraction form. And make sure, so when you are writing this, when you are writing, let's say this qx, make sure this qx should not become 0 for certain value of x, because you can't take those values as domain. If you find those values are making it this qx as 0, denominator as 0, so just exclude them, because this function needs to be defined. Always remember this. So these are two different polynomials and this qx should not be equal to 0. Should not be equal to 0. The domain will be all the real number minus where qx is becoming 0. Range, for range you can simply find out the range. You can just equate this to y and then find out for all the values of y whether you are getting pre-images or not. So you can just use that and you can exactly find the value of y. Got it? Now let's talk about explicit function. So this explicit function is when you can write y. Sometimes what happens that you can't get function in form of x like this. Simply on right hand side we see x terms and on left hand side we see y terms. We generally always get these sort of functions. Sometimes what happens, instead of getting like this sort of thing, we get, let's say, an equation in terms of x and y like this: x square y plus 2 plus let's say 3y is equal to 0. This sort of equation. Now if using this equation we can represent y in terms of x, then it will be called explicit function. Let's say take this example only. So I can rewrite this as x square plus 3 into y will be equal to minus 2. Then y will be equal to what? Minus 2 divided by x square plus 3. So as you can see that y is being represented in terms of x, that means it will be an explicit function. Sometimes it might happen that you will not be able to represent y in terms of x. Can't be representing y in terms of x, then it will be called an implicit function. I hope everything is clear so far. If you have any doubt, you can just leave a comment. I'll answer it. Okay. Bounded function. So this bounded function is, this tells you that your function is between a particular region. So let's say this m and this is your minus m. This is your y-axis and this is your x-axis. So between this only your function will fluctuate. So this will call bounded function, or it is not necessary that function will fluctuate. It might also happen that function will have value between this region only, and here this m is your finite positive real number. Clear? Now what is this identity function? So identity function is basically here the element from the domain, it gets connected, or you can say it has a value, or it has an image which is equal to this element only. What I mean to say is, if I write f of x, I should get x, and this is not for one value of x, for all the values of x that belongs to domain. Let's say a is your domain here. This is your identity function. For an example, you can take y is equal to x. This is an identity function. Okay. Let's move ahead. Now we have modulus function. So this modulus function gives you what? Always positive value. Now let's break it down. Let's say if you have got x greater than 0. So for positive x, don't you think the magnitude of x will be the same? You don't need to change the sign. But when it comes to negative x, how to get its magnitude's value? You have to just multiply with minus sign. When you multiply with -1, it becomes what? Positive. So we can split this modulus function like this: x for x greater or equal to 0 and minus x for x lesser than 0. Now if you want to draw this, if you want to draw this for x greater or equal to 0, then let's say this positive area, this positive x-axis, in this y is equal to x, so we have a straight line making 45-degree angle with the x-axis. And for negative x, that means left hand side, for this, as you can see, it is y is equal to minus x. That means this, a straight line making 135-degree angle with the x-axis. Clear? So this is a modulus function. Let's talk about its domain and range. As you can see, it is defined for all the values of x. So that means domain will be what? Equal to real number. Whereas if you talk about its range, what is this range? Starting from 0 to infinity. Starting from here and going till infinity. So range would be starting from 0 to infinity. Clear? Let's talk about exponential function. So exponential function is being represented by f of x is equal to a raised to x. Here a is a positive number. Now tell me guys, why can't we have negative number? Think. Any guesses? Think. Okay. The reason is very simple here. If let's say x, if a is your negative, a is your negative number. So sometimes what would happen? It would give you positive. A is your negative number. Now x can take any value from real number. So let's say it might take 1/2 also. So square root of negative number, is it possible? It is not a real number, that will not be defined. That's why we don't have a negative, a as negative. So now a has to be always greater than 0. So here we have two cases. One case is when a is between 0 to 1, and another case is when a is greater than 1. Okay, so now let's draw the graph for these two cases. Now tell me one thing: when you have any number which is more than 1 and we keep increasing its power, what happens? We see it is becoming a large number. The graph would be like this. Okay, so this is when a is greater than 1 and this is the graph for a raised to x. But now let's draw the graph when a is between 0 to 1. Now tell me one thing: when you have a number between 0 to 1 and you are increasing the power, what happens? It becomes smaller than a actual number, correct? So when you see this sort of thing, what happens? Get this sort of graph y, and this is your x, this is 1, and this is a raised to x when a is between 0 to 1. Clear? Okay, now let's talk about its domain and range. As you can see, the function is defined for all the values of real number. And as you can see, what is the range here? Range is very simple. Only positive number starting from 0 to infinity, but this doesn't include 0 here. Okay, the range is 0 to infinity. Clear? Now let's talk about logarithmic function. So this logarithmic function is defined by f of x is equal to log ax. A is here base, and a is always greater than 0, but it can't be equal to 1. Now tell me why. Reason is very simple. See, if you just check log's property, so this log ax can be written as 1 upon log x a. If a is 1, so log 1 is what? It is 0. So 1 upon 0, that won't be defined. So that's why a can't be equal to 1. Is it clear? Now again, here also there are two possible cases when a is between 0 to 1 and when a is greater than 1. Okay, so let's try to draw the graph. Let's draw it when a is greater than 1. When we draw the graph, we get this sort of graph starting from here and keep going up like this, and this becomes 0 when x is equal to 1. So now let's talk about its domain and range. So as you can see, it is only defined for all the positive value of x. The domain will be 0 to infinity, but when we talk about its range, see, it is covering all the values on the y-axis starting from minus infinity to infinity. So range would be real number. Now this is for a greater than 1 case. So now just imagine a is between 0 to 1. In that case, we get this sort of graph. It starts from here and keep going like this, and this is your 1, and this is the graph between 0 to 1. Okay, clear? Again, domain and range would be the same. It is defined for all the positive x, and range is the real number. Clear? Any doubts? Okay, perfect. Let's move ahead. Now let's draw these trigonometric functions. So in this trigonometric function, first we'll start with sin x. So the sin x graph, it looks like this. Here this is pi, this is 2 pi, and this is pi by 2, this is 3 pi by 2, and the maximum value is 1, and this is your minus 1. Okay, now if you talk about its domain and range, as you can see, it is defined for all the values of x. So real number, range will, or your domain will be range, the domain will be real number, and your range, as you can see, it has value between minus 1 to 1, so range would be minus 1 to 1. Clear? Now let's talk about cos x. So in cos x, there is slight difference. The curve shifts towards left by pi by 2, and the curve, it looks like this. And it will keep going on. So this is your pi by 2, this is your 3 pi by 2, this is your 2 pi, sorry, this is your pi, and this is your 2 pi. Okay, and again this is maximum value is 1 and minimum value is -1. So if I talk about its domain and range, my domain would be real number, range would be -1 to 1. Clear? Now let's draw 10x. Now in this 10x curve, I have found many students, they find it difficult to remember 10x graph somehow. That's okay, not an issue. At least I hope in trigonometry you must have marked up 5 standard angles value for 10x, like 10, 0, 10, 30, 10, 45, 10, 60, 10, 90. So just based on that you can figure out other values also. So let's use these values first. As you can see, 10, 30 is what? 1 by root 3. So this is your, let's say, pi by 6, and pi by 4 is your 10 pi by 4 is, that becomes 1. Then your pi by 3, that is, and you get what? Root 3. Then 90, you get what? Infinity. Similarly for negative also you will get same amount, same magnitude values, but in with negative sign. Pi by 4 you get -1. So if, let's say, if I want to draw the graph, let's check it out. What sort of graph we'll get? We get this sort of graph. Starting from here, goes like this. It goes like this. And it becomes parallel to this line. X is equal to pi by 2. Clear? And you see it is being repeated by like this always. It's being repeated in every pi interval. Clear? So this is your 10x graph. Clear? Now if you want to talk about its domain and range, as you can see it is not being defined on the multiple of pi by 2. Now what multiple? Even or odd? Correct. Odd multiple. It is not defined on the odd multiple of pi by 2. So I'll just take out those values from real numbers. So that would be what? 2n plus 1 pi by 2. And here n is what? N belongs to integer. And if I talk about its range would be what? As you can see, it is covering all the values of y, starting from -infinity going till infinity. So range would be real number. Clear? Okay. Now let's cover another 3 trigonometric functions. So those are cosec x, sec x, and cot x. Let's draw this cosec x. Now tell me one thing. This cosec can be written as 1 upon sin x, right? So tell me one thing, where exactly this sin x is 0, because 1 upon 0, that would not be defined. We have to just focus on that point. Yes, correct, absolutely right. It becomes 0 at 0, then your pi, 2 pi. So on these value it would head towards infinity, correct? So let's say this is your pi and this is your 2 pi and this is your 3 pi by 2. And at 3 pi by 2 we get what? 1 upon -1. So if I draw the graph would be like this. And this function repeats itself. So you will be seeing again like this for another pi interval. Okay, so now if I want to talk about its domain, so tell me one thing. Its domain will be what? Any guesses? Yes, real number minus. Now tell me one thing. On what all values this function is not defined? Correct. Integer multiple of pi, be it pi, 2 pi, 3 pi, 4 pi, -2 pi. So n pi, I'll be excluding these numbers. And here n belongs to integer. And if I talk about its range, what would be the range? As you can see, it starts from minus infinity, comes till -1. So starting from minus infinity comes till -1 union, and it starts from 1 and goes till infinity. Clear? Now let's draw the sec x graph. So in sec x graph, let's talk about where exactly this cos x becomes 0. Correct. It becomes 0 when we have pi by 2, when we have 3 pi by 2, or in other language you can say when we have odd multiple of pi by 2. Correct. So if I want to draw its graph, let's say this is minus pi by 2, this is pi by 2, and let's say again we have 3 pi by 2, here we have pi, and then we have 2 pi. Let's draw its graph. When x is 0, we have cos x as 1, so 1 upon 1 we get 1. So we'll have this sort of graph, and for this interval we'll have this sort of graph, because in second and third quadrant your cos x is negative. Now if you want to talk about its domain, now tell me what will be its domain. Any guesses? Yes, you can, that's not a big deal, you can just guess it very easily. Correct. Real minus odd multiples of pi by 2. N belongs to integer. Whereas if I talk about its range, as you can see, it starts from minus infinity, goes till 1, then starts from 1 again and goes till infinity. Clear? Okay. Now let's draw the last trigonometric graph, that is your cot x. And it looks like what? Cos x upon sin x, correct? So now tell me guys, again, the way you remember the standard 5 angles value of 10, similarly you can remember the values of cot x also. So tell me one thing. So when x is 0, so your cot x will be what? Cos upon sine, infinity. So it will be somewhere here. Then at pi by 2 it becomes 1, and let's say pi by 6 it becomes 1 upon root 3. Then pi by 2, what? Pi by 2 is what? Cos upon sine. Cos becomes 0, sine is 1, so 0. And till pi we will be drawing the values. Okay. So it looks like this. And it goes till infinity. Now if I want to talk about its domain, as you can see, it is not defined when we have integer multiple of pi. So real minus integer multiple of pi we'll exclude, and that belongs to integer. And if we talk about its range, as you can see, it is covering all the values of y, starting from minus infinity going till infinity, so real number. Clear? Any doubt so far? No? Okay, now let's move ahead. Now we'll go to inverse trigonometric function. Now you might say, what is this first inverse trigonometric function? So just to give you a slight idea, I tell you, see, so let's say your y is equal to f of x, and that is, let's say, sin x. Now this x can be written as sin inverse y. So as you can see, this function is called inverse function. And if you use the same function, so what do you get? X. What is y here? Y is sin x. And the sin inverse sine that gets cancelled out, it becomes an identity, and it gives you again x. Okay. So this sine inverse is exactly, we call it inverse, opposite of trigonometric. It connects all the part of y to x, but there is a catch. Now let's talk about the catch here, because if you just look at all the trigonometric functions, so those are minimum. What do you think? Because if you draw parallel line to the x-axis, though those parallel line to the x-axis, they are cutting the curve at multiple points, so minimum. So that's why when we are defining the domain for these functions, we have to just restrict ourselves. Let's go ahead. Okay, so this sine inverse x, here the range becomes domain. So the range of sine x was -1 to 1, so domain here will be what? -1 to 1, whereas the range will be what? This will be starting from -pi/2 to pi/2. And if you want to see the graph, so graph is very easy. This is x and this is your y. Now range -pi/2 to pi/2, so let's say this is pi/2 and this is your pi/2. This is your, let's say, 1 and this is -1. Now you might ask, yes, why it is not going beyond pi/2? The reason is very simple, because for every value of domain's element, you should not get multiple values of y, because otherwise if that happens, then this function won't be defined. Clear? Okay, so for -1 we get -pi/2, for 1 we get pi/2, for 0 get this. So if you want to draw the graph looks like, any guesses? Yes, absolutely right, the graph looks like this. Like this. Okay, now similarly for cos x, the domain would be the same, starting from -1 to 1, and range would be different. This would be 0 to pi. And if you want to draw the graph, okay, so let's say this is your y, this is your x. For when it is 0, x is 0, you get what? 1. Sorry, when this is your 1, this is your -1. When you have 1, you get 0. When you have -1, you get pi. So let's say pi is here. But when you have your domain, your x value is 0, you get pi/2. Now if you want to draw the graph, now tell me, how will it look like? Any guesses? Yes, it's easy. It would look like this. Like this. That's it. Now tan inverse x. So for tan inverse x, your domain would be what? Okay, now tell me, what was the range for tan x? Correct, real number. Domain would be real number. And if you want to talk about its range, any guesses? -pi/2 to pi/2, correct. Okay, now tell me one thing. So will it include -pi/2 or pi/2? Yes or no? Yes, it would not. -pi/2 to pi/2. Clear? Now let's draw the graph. This is x and this is your y. Domain is all the real numbers. Range is -pi/2 to pi/2. Okay, now if you want to draw the graph, let's say when x is infinity, you get pi/2. So it comes here. When you get -infinity, you get the value -pi/2. So somewhere here. When you get the value as 1, get pi by 4 exactly in between. Similarly, when you get -1, get minus pi by 4. So if I want to draw the graph, so the graph will look like this. I'm sorry, I'm not good with drawing here, but I hope you'll be able to understand what I meant here. Clear? Now let's move to another 3 set of inverse trigonometric functions. So we have cosec inverse x. For cosec inverse x, let's try to draw it first. Okay, let me tell you the domain and range first. Okay, now tell me, for cosec x, what was the range? Any guesses? Correct. So range was -infinity to -1, union 1 to infinity. Correct. Now let's use that only. That would become domain here. So your domain would be -infinity to -1 union 1 to infinity. And if I talk about its range, what will be the range here? Any guesses? Yes, correct. Minus pi by 2 to pi by 2, but there would be one single point that would be missing. Tell me. Yes, come on. Now tell me one thing, where exactly you get infinity? At 0. Yes, let's exclude that point. Simple. Yeah. So now if you want to draw it, so let's draw the domain first, starting from 1 and going till infinity. This is -1, it is going till -infinity. Okay, fine. Now we have got range between pi by 2 to this minus pi by 2 to pi by 2. Now for 1 we get pi by 2, and when this becomes infinity, when your input is infinity, we get 0. Okay. Now when we get when we put domain as -1, what do we get? We get minus pi by 2 here, and when we put somewhere on -infinity, it goes till here. Okay. The graph will look like this. Clear? Any doubts so far? Okay. So Adya, do you have any doubt? If you have any doubt, you can just ask. Similarly, for sec inverse x, we can draw the graph also. So now tell me, for sec x, what was the range? Because that would become domain here. Okay, so the domain would be the same, -infinity to -1 union 1 to infinity. And if I talk about range, guesses? Yes, 0 to pi minus. Now tell me one thing, where exactly we get this infinity? Correct. At pi by 2. So our domain would be 1 to infinity, and here -infinity to -1. Range would be 0 to pi, excluding this point, pi by 2. Now when I put x, x is equal to 1, what do I get? I get 0. And when I put -1, I get pi. So this sort of curve I would get. Here, this is your sec inverse x graph. Now if you want to draw cot inverse x, so let's talk about its domain and range first. So here cot x range would become domain here, cot inverse x. So domain would be what? Absolutely right, all the real numbers here. And when I talk about its range, that would be 0 to pi. But yes, tell me one thing here, would you be including 0 and pi? No, that's good. So 0 to pi. So this is your range. So 0 to pi. I'll just erase something so that it would become clear for you guys here. I'll write it down. Any doubts? Other, yes, other doesn't have any doubts. That's really good. So your range is 0 to pi. Okay. So this is your 0 and this is your pi. Here. Okay. So now when I put let's say infinity, what do I get when I put infinity here? Yes, it goes still. It is what? Cos upon sine. So you can just recall the values from normal cot x function. That will help you the most. So when you put cot x, so when you put this infinity, what happens? Good. When you put infinity, it becomes somewhere here. When you get infinity, so it comes somewhere around here. Why? Because cos x upon sine x. So cos x is your 1. The sine x, that needs to be 0 because it is 0. Correct. So infinity ke liye, for infinity we get this value 0. Similarly here for minus infinity we should get value pi. So if you want to draw the graph, that would be somewhere like this sort of graph. Yeah. Any doubts so far? I hope you don't have any doubts. If you have any doubts, you can just drop a comment. I'll clarify doubts. Let's move ahead. Now we have greatest integer function. Now this greatest integer function is defined for all the values of real number, and this is what? So basically this gives you the lower greatest integer. So this x, let's say it could be any number, but when you apply this greatest integer function, it gives you just any number which is just lower but greatest integer of x. So what I mean to say is, when I put x is equal to, let's say, 3.5, the greatest integer would give me what? 3. Now if I want to draw its graph, let's see what happens. So 0 to, let's say, 1, 2, 3, let's say till here 4, and here let's say -1, -2. Now if let's say number is between 0 to 1 but not 1, so I'll be getting 0 value. So what I'll do is I'll just change the color so that you can easily see the graph here. So 0 to 1, but 1 is missing because when it becomes 1, we get the integer, and lower than 1, what is the integer? It's basically 1 only. So here again 1 to 2 but not equal to 2. So we'll keep getting 1 all the time, greatest integer function's value, but when it comes to 2, the greatest integer will give us 2. Similarly here, like this. So we see one sort of step function. People call it step function. Okay. Now if you just look at the range, as you can see, it always gives you what? Integers. Correct, it is giving you integers. So here domain would be your real number, but your range would be integers. Now let's talk about fractional part. What is this fractional part here? This fractional part is, this is represented by x minus greatest integer of x. Now tell me one thing, when you are reducing or you are subtracting the greatest integer from x, what do you get? You would get any number which is varying between 0 to 1 but not 1. Correct? So it is defined for all the values of x that belongs to real number, and if you want to draw the graph and you see, the graph would look like this. let's say this is 1, this is 2, this is your 3, this is your -1, and let's say this is -2. So let's check it for this interval 0 to 1. So when you make it 0 to 1, so in 0 to 1 this greatest integer is what? 0. So it becomes what? Y is equal to x. So it becomes a straight line passing from the origin, correct? So this sort of graph 0 to 1 but not equal to 1. Okay, till here. Now between 1 to 2, then it becomes what? X minus 1, correct? So let's say that here -1 intercept, and we'll be having a straight line and it will go like this. So if you keep drawing for every interval, you get this sort of graph. And when I represent this dot means the integer is missing here. This 1 is missing here. Clear? Okay. So range for this function would be what? Range would be 0 inclusive, but 1 is not included in this. So 0 to 1. Now let's talk about signum function. So signum function is being represented by like this. Mod x upon x when x is not equal to 0, but when x is equal to 0, it is 0. If you want to rewrite, if you want to open the mod, then it becomes x upon x when x is positive. When x is 0, it's 0. When x is negative, it becomes minus x upon x. That means this becomes 1 and this becomes -1. And if I draw it and I see this sort of graph, this is my x and this is my y. I'll just change the color. So I'll have here 1 and here I have -1. So it starts from here, it goes till here. So range would be what? Only 3 numbers are there in the range. So -1, 0 and 1. So this is the range of this signum function. Let's go to maximum and minimum function. So this maximum and minimum function is basically max of g1x, max of g1x, max of g2x, max of g3x till gnx. Now what does that mean? That means it is defined for, let's say, a certain value of x, any interval is given. So in that interval you have these different functions. So whichever function gives you the maximum value, we take that function out as an output. For an example, let's say if I define a function max of sin x between, let's say, 0 to pi. Your x belongs to 0 to pi. Now let's draw the graph. So when I draw the graph for sin x, so this is like this. This is 1, this is your 0, and this is your pi, and this is your pi by 2. Pi is what? 3.14, correct? And if I divide that by 2, what would I get? 1.57 somewhere on value, correct? Now let's draw the y is equal to x thing. When you draw y is equal to x, so it becomes 1 here, and it will keep going till pi. Okay. Now if I talk about the maximum of sin x cos x, as you can see, the red line is slightly up in the beginning, then it goes down. So for this interval, so for till here, till this when this line cuts the sin x curve, we'll show maximum would be sin x. The moment it cuts the x-axis, the moment it cuts the line y is equal to x, then we see this y is equal to x line becomes maximum of these two functions. So we will take that value. Clear? So if I want to represent the graph of this function, that would look like this. Till here like this, till it is becoming 1. So this value would be what? Sine inverse 1. So till here sine inverse 1, then after that it will be a straight line going till pi. Here. Okay. Similarly, minimum function. So minimum function gives you the minimum value of these functions for a certain interval. And again, the domain would be defined in the function itself, and range, again, that depends upon the function, the way the function is defined. Here. Okay, let's go ahead. Now we have these two more function, odd, even function. So odd function is basically a function when we put, instead of x, when we put minus x in it. If we get minus of f of x, then we call it an odd function. But if we get f of x only, then we call it an even function. For an example, for odd function, the really good example would be sine x. You put minus x, it becomes what? F of minus x is what? Sine of minus x. This would become minus of sine x. Similarly, for even, we can take the good example would be cos x. F of minus x is equal to cos of minus x, and this would give you what? Cos x. But sometimes what happens, people, they are either not being able to take minus sign in common, or this minus sign doesn't get absorbed, but they still want to check even and odd function. So what they can do is they can just check this thing also, f of x minus f of minus x. If that gives you 0, that means the function is, and if f of x plus f of minus x becomes 0, that means this function is odd. You can try these equations also, because sometimes it happens, and it is not necessary that function has to be either even or odd. It could be none of them also. Clear? Now what is this periodic function? So periodic function is when function repeats itself after a certain, or you can say after a finite value. That finite value is called the period t. So as you can see, f of x is equal to f of x plus t, and this t, post this t, you see this function is repeating itself. The really good example would be your trigonometric functions. You can take sine x. As you can see, after 2 pi, you can see it is repeating itself. Same goes with tan x also. Same goes with cosec x also. And one more thing I would like to tell you guys. So if we get period as t for a periodic function, for integer multiple of period also, we would get the same value. So nt would also give us the same value, and here n is an integer multiple. Yeah. Okay. And this thing should be defined for all the values of x. Let's move ahead. Now let's talk about how to draw the graphs. When we know all these standard functions, now how can we use them to draw the graph of a given function? They just make a few changes and then they ask. So let's see what happens when we add a constant to independent variable. Now what does this independent variable means? Basically x. So what I mean to say is, let's say if a function is defined to you like this, y is equal to f of x. Now what you did is you just change the function, you made it like, let's say, y dash, and the function became f of x plus a. Now you want to draw it. Now tell me one thing, guys. When you put x is equal to 0, you get f of a, and this is the value of the function which was there at x is equal to a. So as you can see, the function has shifted towards left. What I mean to say is, for an example, we can take could be, we can take a linear function, let's say, just to make you understand. Y is equal to, let's say, x. This is your normal curve. Now in this x, I added, let's say, 1, and I made it y dash is equal to x plus 1. Now if I want to draw it, as you can see, at x is equal to 0, I'll be getting what? 1 here. So for all x, I would be seeing all the values are being shifted towards left. So whenever we add a constant to independent variable, we see the curve has shifted towards left. So you can write, whenever we add whenever we add a constant to independent variable, we see a shift towards left. But when we add a constant to dependent variable, then what happens? When we add a constant to dependent variable, so what I mean to say is, let's say y is equal to f of x. Now you made it y plus a is equal to, now you made a new function, and that is y dash is equal to f of x plus a. This is your dependent variable y, and you added this a. So this is a new function. As you can see, every value of this function will be lifted up by a. So if, let's say, this was a function, now I've added a, so every value will be lifted by a. So I'll be getting a new function like this. Here, everything is lifted by a. So dependent variable, a lift in the upward direction. Clear? Any doubts? Okay, let's go to next point. Multiplication of a constant to independent variable. Now when we multiply a constant to independent variable, so what I mean to say is, let's say I make it y double dash is equal to f of ax. So what happens? Curve shrinks, and I'm considering this a is what? A is more than 1. So basically what happens? Your curve shrinks. The good example could be, let's say I draw sin x curve, y is equal to sin x. Now I want to draw y is equal to sin 2x. So as you can see, at x is equal to pi, I would get the same value what I get for sin 2x. So basically, in half of the cycle, I'll be covering my entire cycle for the new function. Correct? So basically, the curve has shrunk. So whenever we multiply a constant to independent variable, our curve shrinks. If we multiply a constant to a dependent variable, then what happens? Let's say y triple dash is equal to a f of x. It just function magnifies. So this sin x curve will become like this. When we were having maximum value at 1, now we'll have at a and minimum at minus a. I'm assuming that a is greater than 1. When a is less than 1, then obviously it would shorten. That's it. Okay, now let's go to third point. When we multiply to minus 1, and this multiplication of minus 1 to independent variable, what does it change? When we multiply minus by minus 1, eventually we are just changing the positive x-axis into negative and negative x-axis into positive x-axis. I'll try to make you understand. It's okay. Let's say y4 dash is equal to f of minus x. Now just see, whatever value of whatever value of f of x you are getting for a certain value of x, the same value we'll get here, but for the negative x. Why? Because it's minus x. So minus minus will become plus. So eventually we'll have the same value what we were getting here for x. So what would happen? There would be an interchange. There would be an interchange between positive and negative x-axis. So now this would start working as a positive x-axis, and this would start behaving like a negative x-axis. So what I mean to say is, if I have sin x curve and if I want to draw it now, so that curve would look like this. like this. This is your sine minus x. Here. Now, if we multiply this minus sign, this minus 1 to dependent variable, then what happens? Tell me. Let's say y1 is what? Minus of f of x. Very simple. Your y-axis thing flips. Or you can say a function flips. So whatever positive value we were getting in the beginning, now they would become negative, and negative would become positive. So negative, and it will become positive. That's it. This is your f of x, I'm assuming, and this is your minus of f of x. Here. Now, when we apply modulus to dependent variable, then what happens? Okay. When we apply modulus to independent variable, so what I mean to say is, let's say y2 is f of mod x. Basically, what you have done is you have converted, or you have converted the negative x-axis into positive x-axis. So basically, on both the sides you have positive x-axis. So when it happens, so whatever the graph you are getting here for positive x-axis, you will be getting the same graph for negative x-axis also. In that case, what happens? Very good observation, that your y-axis starts behaving like a mirror. So whatever is there on the right hand side of the y-axis, the same thing you see on the left hand side of the y-axis. And now when you apply this, let's say y3 mod of f of x, this mod sign to dependent variable, then what happens? Very easy. Then your dependent variable, it takes all the values in the positive y direction. That means whatever is below x-axis, that would become positive above the x-axis. So let's say we have sin x curve, so sin x curve mod sin x would become like this. Whatever was there down, it would flip up. Everything would be positive. Now, when we add two functions, so what would happen? When we add two functions, so the way I solve questions, you can also use the same thing. So you draw two curves simultaneously on the same graph like this. Let's say one graph is like this, another graph is, let's say, like this. Now when someone says add both of them, what will I do? I'll just, for the same x, I'll add this value and this value, and I'll draw the graph. Simple. So resultant, if I draw resultant here, so what would happen? This plus this, okay, so let's say somewhere here. Similarly, this plus this, okay, so this would become like this here. Let's say here, this plus this, so somewhere here. So if I draw the graph, this would give me somewhat like this. Understood? So whenever you get addition or subtraction of two functions, I would suggest you guys draw both the graphs simultaneously on the same graph, so that yes, you can visualize and you can draw the graph. So far, I guess it's a very heavy knowledge today I have given you guys, and a lot to remember. But I would request you guys to just revise it properly, so that we can solve more questions tomorrow. But before that, let's solve a few questions. And I would tell you, why this graphical approach is very important, and why I prefer this more. Because using this graphical approach in many questions, I'll be able to solve those questions within 30-40 seconds. Otherwise, if I use a mathematical approach, either I'll not be able to solve those questions, or I end up consuming a lot of time. So this approach is very beneficial. It gives you the visualization of the questions. So we can have this first question. The question is, find the total number of solutions sin pi x is equal to mod ln mod x. Okay. Now, I'll give you one tip. The very first tip is, if let's say you don't know about the graphical approach, now tell me one thing. Do we have any mathematics which deals with trigonometric and logarithmic simultaneously? No. We don't have any maths till 12th so far. So for that, I would request you guys just use graphical approach whenever you get these sort of questions. When you have two different functions, and you have to find the number of solutions, or maybe sometimes solution also. Better go for this approach, this graphical approach. So how to solve this? Again, so when you are supposed to solve this question, you better draw both the functions and see where exactly they are becoming equal. Let's say this is equal to y, both are equal to y. So let's draw both of them here. When I draw sine pi x, so this is 1 and this is, let's say, 2, this is 3, this is 4, and similarly here -1, -2, -3. And if I draw it, so what do I see? I see it starts from here. Okay, it starts from here, goes till here, and it goes down again, down, up, and it will keep continue. This is your half. Similarly here also. This is your sine pi x graph. I'm sorry, yes, I made a few small mistakes as in drawing wise. So this is your sine pi x curve here. Now I use the different color for mod ln mod x. Now whatever we have learned so far, we'll be using them. So let's check what is this mod of ln mod x. So here this mod is applied to independent variable as well as dependent variable. So what I mean to say is, we know standard function like this, y is equal to ln x, correct? So the graph of ln x is what? We all know that is like this. Now here what he has done is he has applied mod. That means the negative x-axis is also behaving like a positive x-axis. And when it happens, what happens? This y-axis, this starts behaving like a mirror. Okay, when it starts behaving like a mirror, so that means this would be the curve for ln mod x. Now this guy has made one more change. Now what is that change? He has applied the mod sign to this entire function, to this dependent variable. So ln x mod. What would happen? Everything which is below the x-axis, that would become positive. So eventually the curve would be like this. So I'll draw it for you guys. So here 1, 1. So from 1 it would be like this. But for this area, because for this part it would be positive, so it would come from here and it will be like this. Similarly here also it would be like this parallelly, and it would come here, and then it would go like this. Okay, now tell me guys, are there 6 solutions? Okay, let's do one thing, let's calculate them, we'll see. Okay, so I think there are exactly, if I'm not wrong, I could clearly see solutions are 1, 2 and 2 here, 4 solutions. 4 solutions are here. It's very easy, see, it is occurring once here, and second time here, third time here, fourth time here. That's it. 4 solutions. Here. Okay. Now let's go to next question. Find the range of mod y is equal to x minus 1, x minus 2. This is a tricky question which I think I have not covered in the basic part, but I hope you guys will be able to solve this question. So in this question, see, what is this? Mod y is equal to this. So that means this thing will always be positive, correct? Or greater or equal to 0, I can say, correct? So if I draw this graph, what is this? This is standard graph is what? This is the quadratic and having roots 1 and at 1 and 2. 1 and 2. So see, this sort of graph will be there. I've not drawn the complete graph, just hang on guys. So this is your quadratic, but as you can see, this quadratic is giving me negative values, so this is not possible. I can't take these values. So what can be done? Think. Very good. Okay, so I'll just erase a small part, this first. Oh, okay, so what I'll do is I'll just draw this part first. Okay, I was putting x value and I was getting the values of y. Perfect. Now for the same x values, let's say if I get, when I'm opening it, so I can write it like this, x minus 1 and x minus. Now to make sure this needs to be positive always. Another case, what can happen is this can be the case as well. Given the fact this gives me a positive value. So when can it happen? It can happen when I have this sort of graph as well. Correct? Done? Okay. So this would be the final answer of this question. Any doubts? It's very easy. So my y always, this mod y, this will always give me a positive value. That's it. This x minus 1, x minus 2 should give me a positive value. So when I punch the same values of x, I should get these values. Clear? Perfect. So I hope you have understood whatever I taught you guys today. So again, I would request you guys just close your eyes, because I know it's a very heavy knowledge today, heavy knowledge. So just close your eyes and try revising it. And whenever you have any doubts, you just drop a comment. I'll cross check and I'll reply back. I'll be checking all the comments you'll be leaving tonight, and I'll be reverting them very soon, and maybe in the next class I can clear your doubts. And that's it. So just close your eyes and let's recall whatever we studied today. Let's recall. We studied about polynomial, we studied about greatest integer, how can we draw those graphs if let's say we can't remember them. Let's try recalling everything, whatever we studied. Bounded function, odd even function, periodic function, signum function, greatest integer, fractional part. I know it would take almost 2 hours to revise everything, but yes, it is mandatory because that would make your life easier. Okay guys, we'll conclude our class here, and thanks a lot for being patient, and just don't forget to subscribe Unacademy Plus and Unacademy Iconic and use my code NK001. When you use my code, you'll be getting 10% off. And this Sunday I'll be having a special class on Unacademy platform, so install the application and I'll be talking about all the observations we made during this study, and we'll be solving IIT JEE questions using those observations. I'll show you how these observations, they make your life easier while solving questions. Okay, so thanks a lot. Good night guys. Thanks a lot for being patient, and you can subscribe the channel also, so whenever I take a class you get a notification and you can study. And it's not about me, you get to study with other teachers also. You can study chemistry, you can study physics. So just make sure that you hit the bell icon and subscribe. Okay, if you like the video, you can just like it. Thanks a lot guys, thanks a lot, and do share with your friends. Bye bye, good night.